All right, let's dive into a massive engineering challenge. We're going to design a chat app from the ground up for 30 million daily active users. Now, to put that in perspective, that's like building a brand new messenger service for the entire population of Australia. So, where would you even begin?
Here's our game plan for today. We'll start by wrapping our heads around the scale of this thing. Then, we'll set some ground rules, tackle the big real-time problem, pick our tools, and figure out how to make it all work, even when things break. And finally, we'll look at what's next.
Okay, first things first, let's really grasp the challenge here. We have to understand the sheer scale we're dealing with, because that huge number, 30 million, is going to dictate every single technical decision we make from here on out.
30 million daily active users. This isn't just a number, it's a fundamental constraint. At this kind of scale, every choice has to be absolutely ruthless in its efficiency. There's just no room for waste, not a single byte.
So, how do we approach a problem this complex and turn it into a clean, working system? Well, the very first step isn't about writing code. It's actually about building a solid blueprint by setting some very clear ground rules.
Right, before we design a single component, we have to know exactly what we're building. This means defining all of our requirements, what it does, and just as importantly, how it behaves. Think of this as our mission checklist.
First up, what does the user actually get to do? These are our functional requirements. We're keeping it focused, one-on-one text chats, but with all the real-time bells and whistles you'd expect. Typing indicators, read receipts, the works. Plus, it has to work offline and send push notifications.
And then there are the non-functional requirements. These are just as crucial. They're the behind-the-scenes promises. The app absolutely has to be scalable for our 30 million users. It needs to keep data consistent even when offline, and the data stored on the phone has to be totally durable and trustworthy.
With our checklist ready, we can now face the biggest technical puzzle of all. How in the world do we make millions of conversations feel instant without our servers completely melting down? This is the real-time dilemma.
Well, one of the earliest ways to do this was polling. It's basically like a kid in the back of the car asking, "Are we there yet? Are we there yet?" every 5 seconds. Yeah, it works, but it's incredibly noisy and wastes a gigantic amount of server and network resources.
So then came a smarter approach, long polling. In this case, the client asks its question once, and the server just waits. It holds that connection open and only replies when it actually has news. It's way more efficient, but holding millions of those connections open can still be a huge strain on the servers.
So this table kind of lays all our cards on the table. We've got the polling methods we just talked about, but also some more advanced options. You've got server-sent events, or SSE, which is like a one-way street for the server to push data down to us. And then you have WebSockets, which are the real deal, a true two-way highway for instant back-and-forth communication. After looking at all the pros and cons, the answer becomes pretty clear. The best solution isn't just one of these things. It's a hybrid. We're going to use the right tool for the right job, combining good old reliable HTTP with the power of WebSockets. And here's how that beautiful hybrid approach works. For anything the client starts, like you sending a message, we just use a simple, standard HTTP request. It's reliable and gets the job done. But for everything the server needs to tell us instantly, a new message arriving, a typing indicator, we keep that low-latency WebSocket connection open. It really is the best of both worlds.
Okay, we've locked in our communication strategy. Now we can zoom in and focus on the mobile app itself. How are we going to build the architecture on the user's device? How do all the pieces fit together?
We're going to use a classic, clean, layered architecture. Right at the top, you have the UI layer. That's everything the user sees and touches. Underneath that, a data layer is the brain, managing all the information. And at the very foundation, a rock-solid data storage layer to keep all our chat history safe. So, for that storage layer, we're going with a relational database, something like SQLite. Now, why is that? Well, think about it. Chat data is naturally structured, right? Messages belong to conversations, they have users, they have statuses. A relational database is just perfect for managing all those connections efficiently and keeping our data reliable.
Now, here's a crucial point. A great design doesn't just work when everything is perfect. A truly great design has to be resilient. It has to handle the messy reality of mobile networks, where you are guaranteed to have things go wrong.
This is the classic problem every mobile developer has to solve. Your user types a message, hits send, and then their train goes into a tunnel. The network is gone. What happens now?
The answer is a smart, patient retry system. When a message fails, we don't just give up. We mark it as failed and schedule a retry using a strategy called exponential backoff. This just means we increase the wait time between each attempt. We wait 1 second, then 2, then 4, and so on. This is smart because it stops us from hammering a weak network and gives it a chance to recover.
And what about keeping the conversation in order? We can't have messages showing up all jumbled. So we use a clever two-part system. For any message that's successfully sent, we use a universal ID from the server as the single source of truth for ordering. But for those messages that are still trying to send or have failed, we sort them by their local timestamp and just keep them at the bottom. That way, the user always sees what's happening instantly.
Okay, let's move to our final section. How do we keep our users in the loop, even when the app is closed and in their pocket?
And that, of course, is the job of push notifications. But here's the key. We don't actually send the message content in the notification. That would be really inefficient. Instead, the notification is just a super lightweight, battery-friendly tap on the shoulder. It's just telling the phone, hey, there's something new waiting. Open the app to see it.
And there we have it, a solid foundation for a chat app that can handle 30 million users. We've built a scalable, resilient, and efficient system. But, in engineering, the job is never really done. So what's the next big mountain to climb? Maybe it's making sure every single message is totally private with end-to-end encryption. Now that is a whole other challenge.